So for the extra credit, I will be doing the polyprotic oxyacids, and first one I'm going to be doing is H2SO4. First step will be calculating the valence electrons. So if I put that into my calculator, that would be, total is 32 valence electrons. Okay, so here's the first structure that I have for H2SO4. Sulfur is going to be our central atom. There are 4 oxygens surrounding it. There's a total of 32 valence electrons. I placed the 2 hydrogens on opposite sides. Here we go. I have 1 single bond for here and a double bond here. The next resonance structure, I would do this as 1, 2, and 3. Okay, so then this would jump here. So then this would become double bond here, 2, 3, 4, sulfur. This would stay the same. And then this is going to jump over here, so this turns into a single bond. So then after that, what we can do is I almost forgot the 2 other lone pair of electrons right here, total of 8 electrons around this oxygen. What also works out is getting this right here and moving it right here without having to move anything else. So then this would turn into so then both sides would have double bonds. And this follows the octet rule as well. So then we have 1, 2, 3 total resonance structures for H2SO4. Here. Okay, so the conjugate base for H2SO4 would be HSO4. So again, the central atom of this is going to be sulfur, and there are 4 oxygens. Let me calculate the valence electrons for this. So this is the conjugate base of H2SO4. My valence electrons was a total of 34 valence electrons, because we also have that negative charge right there. So we're adding 1 more electron right there. So this is a total of 32 valence electrons around it. But now we need the resonance structures for this. So immediately I could see is we could add this right here. So I'm gonna add that double bond right there. Okay, so what I'm gonna do is I'm gonna use these electrons and put it right here. So then this becomes a double bond. And that becomes that. I'm going to do the formal charges. Okay, so here are the formal charges for these 3 resonance structures. So this one, the sulfur ion is going to have a positive charge. Everything else would have a zero charge, except for this oxygen up here. Here are my calculations. So we have a total of what? 1, 2, 3, 4. Let me see. 1, 2, 3, 4, 5. So sulfur is 6, has 6 valence electrons minus a 5, and it has 0 lone pairs around it, so that gets 1. This oxygen right here, that is 6. There's 2 bonds. Take away the 4 electrons around it, that's 0. So that counts for both of these. Now this double bond, that's gonna be 6 minus the 2 bonds minus the 4 lone pairs around it, that'd be 0. And then for the hydrogens, that'll be 1 minus 1 would get a 0. We would have the same results right here. This would be 1. This would be let's see. This would be the 0. This would be the -1, and everything else would be 0. Over here, our sulfur atom would be -1. Oh, no, my apologies. Our sulfur atom would be 0. Yes, our sulfur atom would be 0. It's 6 minus 6, there are 0 lone pairs, and that gets us 0. The O with the double bond, that is 6 minus 2 bonds minus the 4 lone pairs around it, that gets us a 0. That counts for both of these. And now for these, it'd be 6 minus 2 bonds minus the 4 electrons around it, that's 0. And then the hydrogen's 1 minus 1 equals 0. So this would be the most stable one. So going back over here, calculating this, this sulfur ion has 1, 2, 3, 4, 5. So it'd be 6 minus 5 minus 0 lone pairs. That would give us 2, 1. This has a positive 1 charge. And now for, let's do this double bonded. So let's do the double bonded oxygen. So that's 6 minus what? Just 2 minus 4 gets us a 0. The oxygen with all of its with 8 electrons around it, that's going to be 6 minus 1 minus 6. That gets us to -1. This is going to have a -1 charge. And now these electrons were just this oxygen, my apologies, this oxygen with just 4 electrons, 4 lone pairs, 2 lone pairs around it, would be 6 minus 2 minus 4 gets us a 0. This would be 0. And then for hydrogen, that would get 1 minus 1 would be 0. So that's one of the resonance structures for this. Okay, also noted, what I can also do is I can also have this, more preferably, I feel like I could make this, I could have 2 double bonds. So this was the next one's gonna be my first resonance structure, what I'm gonna use for resonance, because I don't this might not be the best structure for HSO4. So the best structure would be O double bond S O H. And then the double bond over here. Okay, so over here, double bonds, that'd be 6 minus 2 minus 4. This is going to have a 0. This is also going to have 0. Over here, this is supposed to have a total of 8 electrons around it. So this is what? 6 minus 1 minus 6, it's going to be a -1. Over here, this is, for this one, it is 6 minus 2 minus 4, that's going to be 0. And then for the hydrogen, it's going to be 0, since that's 1 minus 1. So for the next resonance structure, I could actually, let's see, I could move, I could do 1, 2, 3. So move this here, move this. Oh, this is actually is not supposed to have a total of 8 electrons. I mean, 6 around there. It's only supposed to be 4. Okay, so then this right here would go over here. So then what this would turn into, it would be O. Do my H right there. And then this would be double bond. And then this would be single bond over here. And then my calculations for that, that'd be 6 minus 2 minus 4, that's 0. This is going to be the -1. Sulfur, it will have, let's see, like 1, 2, 3, 4, 5, 6. 6 minus 6, that'd be 0. And then let's see over here, Did I calculate that over here? I'm not sure if I did. 1, 2, 3, 4, 5, 6. That's 6 minus 6. That is going to be a 0 charge. Yeah, 0 charge of 0. This over here, that is 6 minus the 2 bonds minus the 4 electrons. It's gonna be 0. And hydrogen's 1 minus 1. That's 0. The third way to do this would be, let's see, I could do, okay, so now we have this and this. Another way to do it is to move this to get a double bond over here. Yeah, move this to get a double bond over here, and then take this off and move that that bond right here. So then this would turn into S single bond O double bond to become double bond. And then the hydrogen 0, 0, and then this would be -1 right there. And these are the 3 resonance structures for the conjugate base of, let's see, H2SO4. Yeah, and then conjugate base is HSO4, and these are its resonance structures right here. Okay, so another thing to know is like why I wasn't saying that this was the best starting point for resonance structure. It was because this was not stable. So why resonance matters is because it'll show how the negative charges move. And for this right here, as I moved some of the electrons around, I was able to get a more stable charge for these. So these are way more stable than this was. This sulfur atom has a +1. This has a negative, and then there's zeros. Everything else has 0 charges, but this is all 0 charges right here, making this much more stable. Yeah. Next one I will be doing H2CO3. Total valence electron is 24 valence electrons. Our central atom is going to be our carbon. So we have our carbon, and we have 3 oxygens. I'm going to put oxygen over here, and then 2 hydrogens. So this is how I've written out the Lewis structure for H2CO3. We have a total of 24. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 total electrons. Okay, now I'll be doing the formal charges for this, and then I can begin with the resonance structures. And after with the resonance structures, then I'm going to do resonance structures for just its conjugate base, which is just HCO3. Okay, so this has no resonance structures. It'll be just this. This is the most stable. So yeah, this is the most stable. So resonance structures I'm going to do is for its conjugate base. It's HCO3. Here are my calculations. C is 4 minus 0, 0. Double bond right here, 6 minus 2 bonds minus the 4 lone pairs, 0. For these oxygens, 6 minus 2 bonds minus 4 lone pairs or electrons, rounded 0, and then the hydrogens 1 minus 1. Okay, so the total amount of valence electrons for this is 24 valence electrons. So here we have this. I believe we'll only have 2 resonance structures because we cannot do anything on this side. We can only do something to this side. So this has a total, everything follows the octet rule. Now for my formal charges, this is going to be 4 minus 4. This is going to be 0. This right here, this is going to be 6 minus the 2 minus the 4. That's going to be 0. this right here, this is going to be 6 minus 1 minus 6. That's going to be -1. This right here is going to be 0. So that's 6 minus 2 minus the 4, 0. And then hydrogen is going to be 1. Over here, this is going to be the next resonance structure. This is going to be 1, 2, and 3. So then this would become, this would stay the same. This would be double bond over here, because this is going to jump right here. So then it's going to be O. And then I'm going to put a single bond over here. Total of 8 around there. Now the charge for this one, this is going to be 0. This is going to be -1. This is going to be 0. This is going to be 0. And this is going to be 0. And those are the resonance structures. And doing this allows us to move the charges around in it. Allows us to move the charges around.